Welcome to the tutorial for solving system of equations algebraically.
To start off, we will begin with a simple problem, 2x plus y equals 9 and 3x minus y equals 16. To begin solving, you need to decide whether you can solve by substitution or elimination, and you need to do this for each system of equations that you do. This equation will be solved by elimination. First, you will add 2x plus y equals 9 and 3x minus y equals 16 together. The y should cancel out, and you should be left with 5x equals 25. Now you have to divide by 5 to get x by itself, leaving x to equal 5. Step 2 is now that you know what x is, plug it back into the equation to find y. 2 times 5 plus y equals 9. Subtract 10 from both sides, and you should get y equals negative 1. Plug both known x and y back into the second equation to make sure that they are both correct. 3 times 5 minus negative 1 equals 16. 16 equals 16, so these equations both work.
Next, we will try something a little harder. 7x plus 2y equals 16, and negative 21x minus 6y equals 24. For this example, we are going to solve using elimination, meaning you choose whichever variable you want and take the GCF of the two numbers attached to the variable you choose, and you make one positive and the other negative so they cancel out. Now you also need to understand that what you multiply to one part, you must do to the rest of the equation. So I choose to eliminate the x variable because I know that the GCF is 21. To get 21, you have to multiply the 7x plus 2y equals 16 by 3. And because the bottom equation is negative, you only have to multiply by a positive 3. After multiplying, you should get 21x plus 6y equals 4096. Now you write the equation and cross out all the parts that cancel out. In this case, both the x and the y cross out, so you get 0 equals 4,120. It is impossible for 0 to equal 4,120, so your answer is no solution.
Let's try a little harder problem now. The equation is x squared plus 2y squared equals 10 and x squared minus 2y squared equals 18. Step 1 is to add both equations together to cancel out y. You should be left with 7x squared equals 28. Now divide both sides by 7 to get x squared equals 4. Square root both sides and you're left with x equals 2. Step 2 is to plug 2 in for x in either equation and continue to solve to get y alone. I chose to start with the first equation, so 2 squared plus 2y squared equals 10. Square 2 and you get 4 plus 2y squared equals 10. Then you subtract 4 from both sides, and you get 2y squared equals 6. Divide both sides by 2 to get y squared equals 3. Then square root both sides, and you should get the answer y equals square root of 3. Step 3 is to go back to the first equation and plug in 2 for x and square root of 3 in for y. 2 squared plus 2 square root of 3 squared equals 10. If you took the square root of 3, then squared it, they would cancel each other out, so we can cross those out, and the equation is now 2 squared plus 2 times 3 equals 10. Distribute your properties to get 4 plus x equals 10. 10 equals 10. Step 4 is to now do the same for the second equation. 6 times 2 squared plus 2 square root 3 squared equals 18. We already know that the square root of 3 and 3 squared will cancel out, so we can make it easier for ourselves and say that the equation is now 6 times 2 squared plus 2 times 3 equals 18. Square 2, then multiply by 6 to get 24. 2 times 3 is 6. 24 minus 6 equals 18. 18 times 18, or 18 equals 18. These numbers work for both equations.
Now for a challenge problem, we have 7x plus 5y minus 3z equals 16, 3x minus 5y plus 2z equals negative 8, and 5x plus 3y minus 7z equals 0. First, you need to decide which variable you will eliminate. It makes no difference which one you choose, so let's eliminate y first, because we have a positive 5y and a negative 5y. To do this, it's better to use the formula equation 1 plus equation 2 equals equation 4, and 3 times equation 2 plus 5 times equation 3 equals equation 5. You have to multiply equation 2 by 3 and equation 3 by 5, so the variable will eliminate. And 15 is a GCF, so you multiply by 5 and 3 to get negative and positive 15. So you take 7x plus 5y minus 3z equals 16, and 3x minus 5y plus 2z equals negative 8. And you get 10x minus z equals 8. Multiplying equation 2 by 3, you get 9x minus 15y equals 6z and equals negative 24. Multiplying equation 3 by 5, you get 25x plus 15y minus 35z equals 0. Adding both of those together, you get 34x minus 29z equals negative 24. Now that you have two equations with two variables, 10x minus z equals 8 and 34x minus 29z equals negative 24, you multiply both sides of equation 4 by negative 29 to eliminate the variable z, and then add the transformed equation 4 to equation 5 to create equation 6, which is one variable. So negative 29 times equation 4, you get negative 290x plus 29z equals negative 232. Adding equation 5, you get 34x minus 29y equals negative 24, and equation 6 would equal negative 256x equals negative 256. And then you would solve for x in equation 5. So 256x equals negative 256, so x would therefore equal 1. Then you would substitute 1 in for x in equation 5 and solve for z. So you get 34x minus 29z equals negative 24, and add in the 1, so it would be 34 times 1 minus 29z equals negative 24. Negative 29z equals negative 58, so therefore z equals 2. Lastly, you would substitute 1 for x and 2 for z in equation 1 and solve for y. So you'd get 7 times 1 plus 5y minus 3 times 2 equals 16. So then when you simplify 7 times 1 and negative 3 times 2, you'd get 1 plus 5y equals 16, so therefore your y equals 3. So the solution to these equations is x equals 1, y equals 3, and z equals 2.
And this concludes our tutorial. Thanks for watching.